So here we are again regarding the topic Bend's rule. What is this rule about? Bend rule actually যেটা ব্যাখ্যা করে সেটা হচ্ছে VIII-এর তত্ত্ব থেকে আমরা অণুর যে সমস্ত জ্যামিতিক গঠন বা স্ট্রাকচার পেয়ে থাকি সেখানে কিছু ডিস্টর্টেড স্ট্রাকচার বা অ্যাকচুয়াল পজিশন অফ সাম ইলেকট্রোনেগেটিভ অ্যাটমস in that geometry will fit into that structure according to Bend's rule. It's like প্রথমে একটা এক্সাম্পল নেওয়া যাক, ধরে নিই ClF3. This is a molecule where there is hybridization sp3d, sp2 and pd. Now if we draw the structure ClF3, I said, okay, we take it ClF4 actually. So there F will reside as this or F will reside as this. Normally আমরা দেখতে গেলে we get confused okay where the lone pair will reside. We have some normal rules like LPBP repulsion, from there we can also express it, but it becomes more complicated if we see about like SOF4, this one. Why don't we put this oxygen on upside rather than this? We could have put the oxygen in upside or in axial position rather than the equatorial position, but why don't we do that? It has some basic explanation depending upon the LPBP repulsion or the electronic repulsion, and some extra deep explanation depending upon the S character and the P character and the electronegativity with their interrelationships. It's like when we talk about an electronegative atom, যদি আমরা একটা electronegative atom-এর কথা ধরে থাকি তাহলে electronegative atom has its own character to pull the electron density towards itself of the bond. So if there is a bond like a central atom A, it has formed a bond with F and B and C. F has more electron density and thus the bond pair will be towards F, where this will be close to A or B depending upon the electronegativity of or the depending upon the electronegativity difference between AB and S. Now when this electron pair move towards the electronegative atom, the bond pair has its own distance increased. It looks like that. If we have a structure like this, here we see when you put this here, okay, let's B, C, D, E, and here rather than F we assume an G, any atom G which has not that much electron density as F. Now F has greater electron density, thus and G has normal electron density. So this bond pair will remain to this side and this bond pair will remain to up to close to F. Now when it will exert the repulsion in between bond pair and bond pair, these electrons will be more closer to each other than these electron. Thus there will be a less electronic repulsion in case of this one than this one. This is the difference when an electronegative atom is attached to a central atom. Now, whether we put it in axial or it in equatorial plane, how can we explain that? As the electron density of the electronegative atom is much more higher towards itself, it always prefer to overlap with S character, as S character represents more electron density in a well distribution. So always we would like to put the extra electron density in where S character is much more higher. Now how we calculate the S character? In case of hybridization sp, S character is 50%. If it is sp2, S character is this is like this. When we have hybridization sp, S character is normally 50-50. When sp2, 1/3 is S character, so 33%. When we have sp3, 1/4 is S character, that is 25%. And when there is a pd, that is axial bond, there is a pd hybridization, then there is no S character, 0%, and the p character is 100%. Thus electronegative atom, if they are included, they will always prefer to higher S character position. That is why when we are talking about trigonal bipyramidal structure, TBP structure, there is the hybridization is sp3d, that is sp2 and pd, that is sp3d. This pd axis is this one, that is axial bond, and the planar one is, as we all know, sp2 hybridized. Now rather than pd axis, in sp2 hybridization there is more S character, so the electronegative atoms will always intend to reside on this plane, sp2 plane, where we call it equatorial plane. So according to the Bend's rule, always electronegative atoms will intend to reside on the equatorial plane of a TPP structure. And this rule can be justified by simple lone pair bond pair repulsion. Let us take an example of that. We take the example of that one where we talk about SOF4. Sorry, this. As to justify Ben's rule by its rules as well as by repulsion theory. Now, as there is an extra pi bond with oxygen, so this bond has greater electron density surrounding this. Now, bond pair and the pi bond electron density repulsion will here act number of there two numbers of pi bond and bond pair repulsion is there. Here 1, 2 and 3 numbers. So there is more repulsion if we put this pi bond in the axial position rather than equatorial position. And what about Ben's rule? Ben's rule says where there is more electronegative atom, then it will tend to acquire the equatorial plane. Now, we all know that oxygen is less electronegative than fluorine. So, why oxygen is in equatorial plane rather than fluorine? There is the fact like as oxygen has formed a pi bond with H, then there is more electron density surrounding oxygen atom. That is why it also satisfies Ben's rule, like where there is more electron density, it will always favor the more S character. That is why it resides on sp2 plane. So, আমরা যদি বেন্ড রুল থেকে ব্যাখ্যা করতে যাই অথবা যদি নর্মাল রিপালশন থিওরি থেকে ব্যাখ্যা করতে যাই, দুটো ক্ষেত্রেই the fact is same. And Ben's rule is actually the cause of I will not say cause, better. Ben's rule is actually the explanation of this lone pair repulsion theory or lone pair bond pair repulsion theory or this all repulsion theory. Ben's rule is the explanation of this one. Thus, by Ben's rule, we can easily conclude any structure why they are distorted, why the bond angle has been increased or decreased by repulsion of some by insertion of some electronegative atom. Like if we say in NH4 plus no, not this one. For this example, what I have already told, if it was not F, if any of F we replace with suppose H, rather we say we replace 2F with H. This is structure A and this is structure B. In structure A, 2 fluorine atom has been replaced by 2 hydrogen atom. Here we see the angle of OSF and the angle of OSH, this angle is much higher than angle OSF. Why? Because it is more electronegative, so the electron will be near to fluorine atom. Thus, the distance is much higher, much larger. Here, the bond pair fills the distance very smaller with the pi electron density. Thus, the repulsion will be higher and it will bend towards itself. Thus, the angle of OSH is much larger than OSF. এরকম বহু molecule, there are plenty of molecules which structures can be, distortion of structures can be explained by Bend's rule very easily. So, that is all about Bend's rule, and we will look forward for other topics in very near future. For till now, thanks.